Are hurricanes and tornadoes the same thing?
Well, that was Tegan from Lou Henry Elementary School. Thank you, Tegan, for asking that question. First, we want to get started with hurricane formations. Now, the short answer, no, but let's dive into some of the reasons why. To get a hurricane, and you know that's the end product, we have to look all the way back to where these storms or even tropical waves develop, and we're going to use the Atlantic Basin as our example. So tropical waves, you have to start with that, and those mainly generate off Africa. You have the warm, dry air from the Sahara Desert, as well as the cooler, more humid air from the Gulf there. Those combine to create a tropical wave, and that does propagate on westward. Now, along a tropical wave, you could get showers and storms that develop on the eastern edge of that wave. If those continue to develop, that wave could turn into a tropical depression. Now, to get a tropical depression and kind of keep these storms brewing, you need sea surface temperatures of at least 80 degrees. Warm, moist air helps fuel these storms, as well as you need some light winds and low shear. And you can see that here. Light winds and low shear help the storm develop and help the storms continue to grow. With that being said, now any stronger winds or any stronger shear, you're going to rip those storms apart. If it can make it all the way to a hurricane, which we've seen plenty of this year, you're going to have that there, and that's, of course, if there's any land or any kind of cooler waters that can help disrupt that hurricane. Now, the hurricanes are classified on the Saffir-Simpson scale, all the way from Category 1 to about a Category 5 hurricane, and you can see plenty of damage associated with those hurricanes. Now let's talk about tornadoes. These develop on land. You need surface winds as well as stronger upper level winds. When you have these two, it's going to create this horizontal rotating column of air. Now, in thunderstorms, they have updrafts. Updrafts will help bring up some of that air. You can see that being brought in here to help strengthen that storm. Now, when those updrafts bring up that air, that column of air can become vertical and thus tighten, becoming stronger. Now, supercells or tornadoes usually form from supercells with that, and most notably we can tell that there's a wall cloud on that supercell. Of course, supercells have rotation within them. Now, one of the theory states for tornadoes is that you'll have an updraft bringing in warm, moist air, a downdraft bringing usually the air from the thunderstorms is from that downdraft that kind of sinks out and cools. When those two meet, you could get a tornado to form. The tornado has to reach all the way to the ground to become a tornado, and if it doesn't, that's just a funnel cloud. Now, tornadoes are classified on the EF scale, ranging from EF0 from 65 to 85 miles per hour, all the way through to an EF5 tornado, which we know is the most devastating, with winds of up to 200 miles per hour or more, and they usually have that wedge shape. Now, if you want to learn more information about tornadoes or hurricanes, there's plenty to dive into. I wrote up a nice blog on schnacksweatherblog.com. You can take that at kwwl.com, and we will be right back.